Hi everyone, it's Katrina, and today we will be adding and subtracting polynomials, and we will be doing number 61 that we did during class today. So first of all, there are a few basic things that we should know about polynomials. One is that you can only add the basic numbers that have the same exponent. If they don't have the same exponent or the same base, then they cannot be added or subtracted from one another. Another thing is that you have to write them in standard form once you are done, which is ax plus by equals c. So we also need the exponents to go from largest to smallest. So instead of going from basically 1 to 10 on the exponent scale, we would have to go exactly the opposite. We would go from 10 to 1. So a really easy way that I find to set this problem up is to just do it in subtraction form, which a lot of people are more used to, and it makes more sense for a lot of people just to subtract. But there are a few things that we just need to establish before we do this. First of all, this is a double negative, so 3.1 y to the third would end up being positive. 2.9, you would distribute the negative, so it would end up being negative. And negative 4.1, two negatives also equal positive. So that's going to be positive, just so we don't mess that up. So right here, we're just going to section this off because we don't want to add exponents that aren't supposed to be added to each other in this case. So we're going to do y to the thirds over here, y to the seconds over here, y to the first over here, and no exponents in this area. So numbers that just don't have exponents with them. So we're just going to call this NE for no exponents. So y to the third, so we have negative 3.8y to the third. And then we're just going to go along this and put this problem in. So we have 6.9y to the second, negative y, and then 6.3 over here. So we have just done that, so we can just check that off. We're all good. Now we need to put this part of the problem in. Remember, we already distributed the negative before. So we're going to have positive 3.1 y to the third. We're going to have nothing in this area because we don't have any y to the second. Now we're going to have 2.9 y to the first and 4.1. So now all we really have to do is add or subtract whichever we need to do. So we're going to subtract this first. Sorry, we're going to add this first. So it's going to be 3 plus 1 is 4. We already brought down our decimal. And 4 plus 6 is 10. So we have that all set. 2.9y minus a y is also going to equal 1.9y. Oh, I'm sorry, that's actually a negative, so we're not going to do that. Did you catch my mistake there? So, I'm just not going to edit this out because I feel like anyone can make a mistake, so it's going to be easier like that. So we're going to have negative 3.9y. Now for y to the second, we can just bring that down, so we'll have 6.9y to the second. And then for this one, what we are going to do, since we have negative 3.8 y to the third and 3.1 y to the third, it's equaling 0.7, negative 0.7 that is. So y to the third. So we basically have our answer right there. So this was our original problem, but we have simplified it down together to create negative 0.7 y to the third plus 6.9 y to the second minus 3.9y plus 10.4. You might be thinking, why can't we just add all of the y's because they all have the same, they have the same variable. But in this, as I said before, you can only add if they have the same exact exponent. Since this has 3, this has 2, and this has 1, an invisible one actually, we're not going to add them because that's not the way it is. If you have already noticed this is already set up in standard form, ax plus by equals c. So, I just wanted to thank you for watching this video, and yeah, thank you, bye.